Hello students, for class 12, today we are going to upload a video on inverse trigonometric functions. Now, inverse trigonometric functions, important points to remember. Inverse of a function f exists if it is a bijection, means it is invertible function. That is, if the function f is 1 1 and on 2. Now, if f is a function from set A to set B, is a bijection, then there exists a function from B to A such that g of y is equal to x. This is called inverse of the function. If and only if f of x is equal to y. Now, g is a function that exists from B to A is called the inverse of the function that exists from set A to set B and is denoted by, as you know, f to the power minus 1 means f inverse. Therefore, what we get whenever, that is, we have f of x is equal to y, this implies f inverse y is equal to x. Conversely, if it is that x is equal to f inverse y, then we have y is equal to f of x. Now, inverse of sine function. Inverse of sine function. Let us consider the sine function. Domain of the function is R. The set of real numbers and range is -1 and 1. It is the sine function. Now, what is the inverse of the sine function? It is clear that sine function is not 1 1 and onto. And now it is the question, if sine function is not 1 1 and onto, that is not invertible, then how does the inverse of sine function exist? For that purpose, we have to restrict the domain from closed interval minus pi by 2 comma pi by 2. Then f is 1 1 and onto with range closed interval -1 and 1. Thus, if y is equal to sine inverse x, it is the inverse function, then its domain will be -1 and 1 within closed interval, and the range will be -π/2 to π/2. Similarly, for y is equal to the inverse function cos inverse x, domain will be closed interval -1 and 1, and the range will be closed interval 0 and pi, that is 0 to pi within the range. Similarly, y is equal to tan inverse x, its domain is real numbers, the set of real numbers, and its range will be open interval -π/2 to π/2. It cannot take -π/2 and π/2 because tan means sine by cos, and cos π/2 is 0. So whenever the denominator becomes 0, the function becomes meaningless, that is within open interval. Y is equal to cosec inverse x, its domain will be -∞ to -1 closed interval, union closed interval 1 to infinity. Infinity side always open interval. It cannot take the value 0. Y is equal to cosec inverse x, so it will be cosec inverse x. We know cosec x is equal to sin x, and 1 by sin 0. Sin 0 is 0, so function will be undefined for x is equal to 0, and its range will be -π/2 to π/2 within closed interval, but it cannot take the value 0. Y is equal to sec inverse x, so its domain will be -∞ to -1 union 1 to infinity, and its range will be closed interval 0 to pi minus π/2, that is 0 to pi contains π/2, but except π/2, within that limit, within that closed interval, it cannot take π/2. Y is equal to cot inverse x, its domain will be the set of real numbers, and its range will be open interval 0 to pi. My advice to the students is to learn all this part. Whenever the inverse functions are this, its domain and range will be what? They should learn this, because every time it is necessary, mandatory to mention while solving the sum. Now let us discuss the properties. Let us discuss the properties. Number 1, property number 1. What is property number 1? That is, within property 1 we will discuss sine of sine inverse x is equal to x for all x belongs to domain. Cos of cos inverse x is equal to x for all x belongs to domain. Tan of tan inverse x is equal to x for all x belongs to domain. Cosec of cosec inverse x is equal to x for all x belongs to domain. Sec of sec inverse x is equal to x for all x belongs to domain. And cot of cot inverse x is equal to x for all x belongs to domain. Now I am giving you the proof of anyone. You yourself will try to prove the remaining. First one I am doing, showing that sine of sine inverse x is equal to x. Let us assume that sine inverse x is equal to theta. Then sine theta is equal to x. It is the forward function, it is the inverse function. Now sine theta is equal to x for all x belongs to -1 to 1. And theta belongs to closed interval -π/2, π/2. Therefore, sine of sine inverse x, sine theta, sine is sine, theta means sine inverse x. So from this we can write, again see very carefully, sine is sine. Theta, theta means sine inverse x is equal to x for all x belongs to closed interval -1 and 1. Similarly, we can prove other results. Now property 2. Sine inverse of sine theta is equal to theta for all theta belongs to closed interval -π/2 to π/2. Cos inverse cos theta is equal to theta for all theta belongs to closed interval 0 and π/2, 0 to π/2, sorry, 0 to pi. Then tan inverse tan theta is equal to theta for all theta belongs to open interval -π/2, π/2. Similarly, cosec inverse cosec theta is equal to theta for all theta belongs to closed interval -π/2, π/2. There is -π/2 to π/2 x. Okay, theta not equal to 0. That is within this limit -π/2 to π/2, it cannot take the value 0. Sec inverse sec theta is equal to theta for all theta belongs to closed interval 0 to pi, but theta cannot take the value π/2. That is theta not equal to π/2. Cot inverse cot theta is equal to theta for all theta belongs to open interval 0 to pi. Now similarly, I am showing you one proof that sine inverse sine theta is equal to theta. Let us assume that sine theta is equal to x. Then theta is equal to sine inverse x for all theta belongs to closed interval -π/2 to π/2 and x belongs to closed interval -1, 1. Now if sine theta is equal to x, then theta is equal to sine inverse x, implies theta is equal to sine inverse x means sine theta. So what we get, sine inverse sine theta is equal to theta. Hence we have sine inverse sine theta is equal to theta for all theta belongs to closed interval -π/2 to π/2. Similarly, we can prove the other results. A student must try to prove this themselves. Property 3. Sine inverse minus x is equal to minus sine inverse x for all x belongs to closed interval minus 1 to 1. Similarly, cos inverse minus x is equal to pi minus cos inverse x for all x belongs to closed interval minus 1 to 1. Tan inverse of minus x is equal to minus tan inverse x for all x belongs to R, set of real numbers. Cosec inverse minus x is equal to minus cosec inverse x for all x belongs to open interval minus infinity to minus 1 closed interval union closed interval 1 to infinity open interval. Cot inverse minus x is equal to pi minus cot inverse x for all x belongs to R. Similarly, I am showing you one proof. Here I am doing the second proof. Cos inverse minus x is equal to pi minus cos inverse x for all x belongs to closed interval minus 1 and 1. Proof. Let cos inverse minus x is equal to theta, and this is equation 1. Then minus x is equal to cos theta. Then x is equal to minus cos theta. Now minus cos theta means cos of pi minus theta. We know that cos of pi minus theta means minus cos theta because cos enters in the second quadrant sine group. So what we have, pi minus theta is equal to cos inverse x. Theta is equal to pi minus cos inverse x. Now this is equation 2. So comparing equation 1 and 2 we can write, but what is theta? Cos inverse minus x. Therefore cos inverse minus x for theta, cos inverse minus x is equal to pi minus cos inverse x, pi minus cos inverse x. Property 4. Number 1. Sine inverse 1 by x is equal to cosec inverse x for all x belongs to open interval minus infinity to 1 closed interval union closed interval 1 to infinity. Cos inverse 1 by x is equal to sec inverse x for all x belongs to open interval minus infinity to minus 1 closed interval union closed interval 1 to infinity open interval. Tan inverse 1 by x is equal to cot inverse x for all x belongs to R and x greater than 0. Now here again I am giving one proof. Let cosec inverse x is equal to theta. It is equation 1. Then x is equal to cosec theta. Then 1 by x is equal to sine theta, because 1 by x is equal to 1 by cosec. 1 by cosec means sine. So sine theta. Therefore theta is equal to sine inverse 1 by x. But what is theta? Cosec inverse x. So comparing 1 and 2 we can write Sine inverse 1 by x is equal to theta mean cosec inverse x. So it is proved. Similarly, the students will be able to do the other proofs. Now property 5. Sine inverse x plus cos inverse x is equal to pi by 2. For all x belongs to closed interval minus 1 to 1. Tan inverse x plus cot inverse x is equal to pi by 2 for all x belongs to set of real numbers. Sec inverse x plus cosec inverse x is equal to pi by 2 for all x belongs to open interval minus infinity to minus 1 closed interval union closed interval 1 to infinity open interval. Similarly, I am giving you one of the proofs of this three property. Now, let sine inverse x is equal to theta. Then theta belongs to closed interval minus pi by 2 and pi by 2. So, theta lies within this interval. So, minus pi by 2 less than equal to theta less than equal to pi by 2. Now, if we are multiplying by minus, then pi by 2 less than equal to becomes greater than equal to minus theta. Similarly, again less than equal to becomes greater than equal to minus pi by 2. That is minus pi by 2 less than equal to minus theta less than equal to pi by 2. So, if we are adding to this, if we are adding pi by 2, if we are adding pi by 2 to every term of this, what we will get? Minus pi by 2 plus pi by 2 less than equal to pi by 2 minus theta, that is minus theta plus pi by 2 means pi by 2 minus theta less than equal to pi by 2 plus pi by 2. Now minus pi by 2 plus pi by 2, what is this? 0. Less than equal to pi by 2 minus theta less than equal to pi by 2 plus pi by 2, which is pi. Therefore, what we see, pi by 2 minus theta, this lies within the interval 0 to pi, closed interval, since less than equal to less than equal to. Now what we get? Sine inverse x is equal to theta. So we have x is equal to sine theta. X is equal to sine theta is equal to, for sine theta we can write cos of pi by 2 minus theta. Cos of pi by 2 minus theta. Therefore we have cos inverse x. Cos inverse x, because x is equal to cos of pi by 2 minus theta. Therefore, pi by 2 minus theta is equal to cos inverse x. That is, cos inverse x is equal to pi by 2 minus theta. Okay? Cos inverse x is equal to pi by 2 minus theta. Now, if we are bringing theta to this side, that is to the left hand side, it will be plus. So theta plus cos inverse x is equal to pi by 2. Now what is theta? What is theta? Theta is sine inverse x. So sine inverse x plus cos inverse x is equal to pi by 2. So it is proved that sine inverse x plus cos inverse x is equal to pi by 2, since sine inverse x is equal to theta. Now property 6. Tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy, provided xy less than 1, because 1 minus xy. Second, tan inverse x minus tan inverse y is equal to tan inverse x minus y by 1 plus xy. Xy greater than minus 1, because if xy is equal to minus 1 plus 1 minus 1, denominator will be 0 and function will be, there is undefined. Third one, tan inverse x plus tan inverse y plus tan inverse z is equal to tan inverse x plus y plus z minus x y z whole by 1 minus x y minus y z minus zx, provided x greater than 0, y greater than 0, z greater than 0, and xy plus yz plus zx less than 1. Now again I am giving you one proof. There is tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy. Within the limit minus pi by 2 less than, there is open interval, okay, pi by 2, whenever alpha lies between this in the open interval. Let us assume tan inverse x is equal to alpha, then x is equal to tan alpha. Where is alpha? Alpha is within the open interval minus pi by 2 to pi by 2 as it is said. And let us assume tan inverse y is equal to beta. This implies y is equal to tan beta. Again beta lies in the open interval minus pi by 2 to pi by 2. At first we wish to show that xy less than 1. This implies minus pi by 2 less than alpha plus beta, both alpha and beta, less than pi by 2. It is given that xy less than 1. Now x means tan alpha, y means tan beta. So tan alpha into tan beta less than 1. Now tan alpha means sin alpha by cos alpha. Tan beta means sin beta by cos beta less than 1. This implies sin alpha sin beta cross multiplication less than cos alpha cos beta. This implies cos alpha cos beta minus sin alpha sin beta greater than 0, because this side is less than this. So this is greater, greater minus smaller will be a positive quantity, and positive quantity means greater than 0. Cos of alpha into cos of beta minus sin of alpha into sin of beta, that is cos A cos B minus sin A sin B cos of A plus B, that is cos of alpha plus beta is greater than 0. This implies that minus pi by 2 less than alpha plus beta less than pi by 2. Now we have tan of alpha plus beta, tan of alpha plus beta, tan of A plus B. What is the formula? Let us recall. Tan A plus tan B by 1 minus tan A tan B. Similarly, for tan of alpha plus beta, we have tan alpha plus tan beta by 1 minus tan alpha tan beta. That is equal to, but tan alpha is equal to x plus tan beta is equal to y by 1 minus tan alpha, tan beta, that is x into y. So if we are taking tan to this side, means we are taking the inverse of the function. So alpha plus beta is equal to tan inverse of x plus y by 1 minus xy. But what is alpha? Tan inverse x. What is beta? Tan inverse y. So tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. Now here to be noted, tan inverse x plus tan inverse y is equal to pi plus tan inverse x plus y by 1 minus xy if x greater than 0, y greater than 0 and xy greater than 1. If it is x less than 0, y less than 0 but xy greater than 1, then it will be minus pi plus tan inverse x plus y by 1 minus xy. Similarly, tan inverse x minus tan inverse y is equal to pi plus tan inverse x minus y by 1 plus xy if x greater than 0, y less than 0 and xy less than minus 1. Because this is positive, this is negative, positive into negative is equal to negative. And for x less than 0 and y greater than 0, xy less than minus 1. That is tan inverse x minus tan inverse y is equal to minus pi plus tan inverse x minus y by 1 plus xy, provided x less than 0, y greater than 0 and xy less than minus 1. So students, up to this today, we have few more properties which we will discuss in our next video. Till then, okay.